Hello everybody and welcome to YouTube Model Builders Tuesday night Arduino Workshop. Sorry for the delay in the broadcast, but we've been having technical difficulties and hopefully we've got it worked out enough to where we can get the show going here. Want to say go to YouTubeModelBuilders.com. There you can check the schedules for all the live shows. Tuesday and Wednesday shows are at 8 o'clock Central, 9 o'clock Eastern time. The Thursday and the once a month Saturday show with Big Bill and Barry, those are still at 9 o'clock Central, 10 o'clock Eastern time. Also be sure and click on the EMAG and be sure and sign up for a notification. So when the EMAG comes out, you'll get a notification, be able to download it. JD and his team do a great job of it. The EMAG came out about a week ago, and another great issue there, so you want to check that out. All right, I think I want to turn the show over to Chris and see what we can do with this. We're having to kind of put a few band-aids on it to get it to rock and roll tonight, but here's your host, Chris. There you go, Chris.
Okay, can you guys hear me? I apologize for that. The technical difficulties are on my end. My computer is at the end of its useful life, apparently. So hopefully I won't have to bug in and out too many times tonight, and we can keep this thing going, and it'll be somewhat decent quality. But welcome back, everybody. Missed you last month, but Chris Rude did a really nice job of filling in and going over the fritzing. So hopefully you guys learned something from that. Tonight I've got something pretty cool. What I promised last time when we were working with the Wi-Fi, I figured out how to do a Wi-Fi activated turnout, which is, to the best of my knowledge, the first time it's ever been done. I spent a ton of time scouring the internet trying to find a sketch for it or any reference to it, and I wasn't successful in finding any. So if anybody knows of it, let me know. But otherwise, this could be the first time you're ever going to see that. So let's jump in real quick, and I'll show you what we're gonna be doing. Then we'll go back and show you how we did it. Unlike most of these nights where we don't build it until we do it, this time there was just way too complicated. So basically, in effect, what we're doing is I've got this Wi-Fi reader right here, and if I just swipe the Wi-Fi card, then you'll see the turnout move, and I've got it set to move nice and slow. I'm going to crank the camera back down again so you can. Not sure how well that's coming across. So I swipe the card again, and you'll see the points move over nice and slow in the other direction. And kind of the neat thing about it is it's specific to the card that I'm using. I also have an RFID tag in this little keychain, and if I swipe that, it actually reads the tag, but then it won't throw the turnout because it's not the right, doesn't have the right unique ID. So the kind of neat thing I was thinking about that is you could set a master key that throws any turnout, and then you could give your operators a tag like this where it only throws like anything but the mainline turnouts. If you had CTC, you wouldn't want them throwing mainline turnouts. So they could use this to throw their yard turnouts, and then the dispatcher or the layout owner, who's ever the troubleshooter, could come around and then just swipe a tag and throw any turnout on the whole layout. So it's kind of neat. Or you could just take your other tag and program it to the same UID as the other one, and then make a whole bunch of them, give everybody a tag, and they just walk up and throw the turnouts. And it's really kind of neat because I'm going to zoom back out a little bit here. If I take this reader and I hold it underneath the board right now, I can just hit the card on the board over the top of it. It helps if I line it up right. And you'll see there it goes. So you can easily hide this behind there. And this board is like a 1/2 inch thick board, and it's reading that card right through it. So you could easily hide that behind a piece of fascia or somewhere on the layout and never see it. Just have a little mark of some sort that you'd know where to swipe. So something cool I thought we should try, and I got it working, and it wasn't easy, I'll tell you that, but you know, there was plenty of code out there for Wi-Fi activating things like door locks and things like that, and plenty of things with servos, plenty of sketches for throwing servos. But the weird part is there's not a lot of sketches that I could find that would tell you how to throw the servo one way and then throw it back. Just about everything, when you activate it, would go one direction and then maybe move back with a different command, either a different Wi-Fi card for the servo or a push button, you know, a push button for each direction if it was using push buttons. So I eventually found a sketch that we actually did earlier. I remembered we did a sketch where I had a push button, and every time we hit the push button, it would throw the servo back the other way. So what I ended up doing was marrying the two sketches together and getting this thing to work. So I was just kind of move this out of the way, and I'll take you back to step one, and we'll work through this thing from the beginning. So bear with me a second while I bring everything into view here. So this looks like a mess, and it really kind of is, but it's way more than what we need to do the job tonight. What I actually have here, uh-oh, I just pulled some of my wires. That's not good. Okay, that one was the positive. It's 5, or the +3, I should say. Ground. No, I tell you what, we could just take the whole thing apart. But what I actually have here is, all you need really is the servo, the board, and your reader to do what I'm doing. But what I had here set up was the LED and the diode on here were not being used. The push button was just to show you the push button sketch that I used to make the servo go back and forth. And of course the Wi-Fi. So what I'm going to do here quickly is apart, and we can start from the beginning and duplicate how to set this thing up. So if you go back to your bare Uno, and this is my Wi-Fi card is the RC522, or more commonly known as the MF-RC522, and the MF stands for MyFare, M-I-F-A-R-E. So that's a very common and very cheap, readily available Wi-Fi card, and it comes with, like I showed you earlier, the tag and one card, one swipe card.
Hey Chris, one quick second. Do you mean Wi-Fi or RFID?
Oh, I'm sorry, I've been saying Wi-Fi. It's RFID.
Thank you.
I got my brain in neutral. Thank you for that. RFID is what we're doing tonight. Apologize for that. So I'm just going to pull this board apart yet, and really don't even have to use it if we don't want to. And then I'm going to show you something else that I did real quick. I created a site for tonight. Because of this is a sketch, it needed a place for you guys to download it from. We created a website, and we'll use that from now on. And it has access to the sketches that we're going to use. So rather than me giving you a bunch of long URLs that you have to try and type in and figure out, all I'm going to do is give you one. And if you make a shortcut out of it and keep it, we'll have it for every show. So if you want to go ahead right away and type in google.com/view/Arduino Work Shop, all one word. So I was trying to do that in Word before when everything crashed, so a big screen with that. Otherwise, if somebody wants to post that, do we have a chat link we can post that into?
Yes, sir. I'll take care of that for you.
All right, so it's sites.google.com/view/Arduino /view Arduino Work Shop.
Yeah,
All one word.
I got you.
And I'm not going to open it just to save bandwidth. Anybody successfully open it?
I got it.
Okay. So if you post up that URL in the chat link for everybody to see, and I recommend you guys just make a shortcut for that because we'll use it every show. And I'll update it. And you'll see and when you get to that page, you'll see at the bottom there's one that says sketches for tonight's show or something like that. If you click on that, it should take you to my Google Drive where you'll be able to see the 2 sketches we'll use. I'm actually going to go ahead and see if I can not kill my computer and bring that up just so I can share it with everybody.
I could do that if you'd like me to.
All right, let me try it. So far it's not killing me. So I think that'll make it a whole lot easier in the future. So I'm going to start screen sharing. It seems to be working.
Chris, what was that site again? Because I don't think it's working. Sites?
Sites.google.com. And now you should be able to see it in the URL on my page now.
And I'll
right at the
paste
top.
it chat.
And then it would be /view /Arduino Workshop.
View slash.
Hey, Greg, if you just want to go to the chat, the lower left-hand corner of the Hangout window, click that little pop-out. I dropped the link there for you. You just click on it.
So once you get to that page, it says link to sketches for August 2nd workshop, and it'll open up a Google Drive folder. And now my computer's starting to slow down, so I may have to close it, but I'll try and show it to you quick. If you're looking over on the right where my cursor is, that'll just change. If you end up coming in with a view like this with thumbnails where you can't read the whole name of the file, just click on that little grid and it'll bring you back to having the whole file name, a list view instead. So I'm going to close that for now on my computer. And here again, one more time before I close it, is what the website will look like. And I'll update that every show. And now I'm going to stop screen sharing just to save some bandwidth. And I'm going to go ahead and start opening my Arduino IDE. So anybody else who hasn't done that yet, now would be the time. And we'll load up our first sketch. While I wait for that, I'm going to bring up the drawing for how to wire this up. I'll share that with you. So anybody not have any luck getting to the web page, or did it work out okay for everyone? Okay.
Well, it worked for me. I'll tell you that.
And it's working for me now too.
Ah, good.
I must have had a
Now it's
typo
just a
in there
matter.
somewhere.
Just a matter of getting this thing wired up to work for us.
So which sketch do you need us to download?
Well, the first sketch we're going to do is actually one that's built into the IDE. Just to refresh real quick, it'll only take us 5 minutes to go ahead and first we'll wire this up, and then we'll load up the sketch from the library that we loaded last time. And first thing you have to do is get the unique ID of your card. So, okay, I found what I'm going to use here, and I'm going to share that with you real quick. Go back to sharing. Apologize for having to do this on the fly. I was trying to have all this stuff open for the show, and it just was killing my computer. So, all right, can you see that? Should be a picture. Should be a picture of the RFID card as well as the pinouts that we're going to use. So the first thing you have to do is remember that whenever you're using this RFID, it wants 3.3 volts and not 5. If you use 5, you could possibly fry the card. So as you can see, the red right here is 3.3. So if you go ahead and plug that into the 3.3 on your volts on your Arduino, which is right next to the 5 volt. So it'd be the 1, 2, 3, 4, 5th hole from the right in that bank of holes. And then that one can go get plugged right into, if you look on right here where all the pins are, and there's real small writing, you can kind of read what they are. So if you got eye trouble like I sometimes do, it can be kind of hard to read. It's small, so you might want to get your best cheaters on for this. But basically, when you're looking at the card, it's going to be the 3.3 volts is the one to the very right. And right next to that is one that's called RST, which stands for reset. And here it happens to be the one that's showing in yellow. And that we're going to set to Arduino pin number 9. And I'm going to work ahead a little bit, and then I'll give you guys time to catch up. So otherwise, try and work along with me. But the next one is ground. That one's pretty self-explanatory. So shoot that one right to one of the grounds on your Arduino. The next one, NC or no connection. If you look on your, I'd actually say IRQ. I think is what it'll typically say, but that one is not used in any of the sketches that I've run across yet that use RFID. The next one in the green is MISO, M-I-S-O, and that goes to pin 13. 9, 10, 11, 12, 13. Next one after that in orange is the MOSI, and that goes to pin 11. After that comes SCK, and that, that can't go to pin 13. The other one is. I'm pretty sure it's 12. I'm going to have to find a different sketch that shows it more correctly. That one definitely wasn't right. What you do is I'll just.
I think MISO goes to 12.
MISO. On the Uno, MISO goes to 12, and SCK goes to 13.
Yeah, that's what I have.
Okay, let me find.
That's what I have.
Yep, I have actually the old sketch set up on mine, and I agree with that.
Okay, so you all agreed on the 3.3, the RST, and the ground, right?
Yep.
So then we skip the IRQ, and then the MISO you said goes to
12.
To 12, not to 13.
Yeah.
Okay. So 9, 10, 11, 12. And then the MOSI
goes to 11.
11.
Goes to 11. All right. And the SCK, what are you saying that one goes to?
13.
13.
Yep.
And then the SDA go to 10?
Correct. Yes.
Okay. All right. So one more time, going right to left is the 3.3 volt goes to 3.3 volt. The RST, I follow that back, goes to 9. The ground goes to ground. IRQ we skip. The MISO goes to 12. MOSI goes to 11. SCK goes to 13. And SDA goes to 10. So now I'll fire up the camera and show you what that looks like. Let me clear some of this junk so you can kind of see. So there's the top. I'm looking from the side. Follow the wires back. Pretty much what you have. So that's all we need at the moment. If we go ahead and go to your IDE, I'll go back to screen sharing. Switch to my IDE. If you go to the file pull down, examples, go all the way down to the bottom, and hopefully you have this loaded. If not, I'll show you how to do that. Let me know. Last time we were doing this, we loaded this MFRC 522 library from GitHub. So if you don't have that library, let me know right now. And even if you're out on YouTube and you want to work, you're working along with us, just quick post a comment, because I can take you out and show you where we got that. But if you Google it, you'll find it real quick and easy. It's MFRC 522 library. If you Google that, you should be able to find it and load it. But there's within that, they have an example. Oh, come on, called dump info. So this is a simple little sketch that turn on your serial monitor after you load it. So I'm going to plug my Arduino back in and make this full screen. Just scroll down to show you.
I sent the link to Andy for it if he wants to post it.
Very good, thank you. So as you can see, it's a very short sketch. Most of it is just comments in the light gray. There's only a few lines of code here, which we don't even really have to worry about. I'm just going to go ahead and hit upload. And this is what's going to take mine. This will give you guys time to catch up while we wait for my slowpoke computer to compile the sketch and upload it. I noticed when I'm streaming, it really makes a big difference, because when I was spending time working on this just being offline, it was no problem. But the other night I was on a Hangout showing this to the guys, and every time I'd go in to try and I actually connected it to a turnout for the first time, so I needed to make some adjustments to the throw and the speed. And boy, when I'm streaming like this, it just kills the amount of time that it takes to compile and upload. So the other thing, believe it or not, was the video camera. When I unplugged my video camera, it actually sped up considerably. But my good friend Andy Crawford has got a computer sent on its way to me, so hopefully by the next show we'll have all these problems solved. Appreciate that, Andy. Hats off to you.
Absolutely. What are brothers for?
The moral of the story is don't try and run on a live show off of a $250 Walmart laptop. All right, so mine's done uploading. As you can see, it says right here. So now the next thing I do is just start the serial monitor. And if I take my little RFID card and swipe it in front of the reader, no, sorry, I did the serial plotter. I'm like, what are those funny lines? Must have misclicked. There we go. Let's try it again. So as soon as you start it, you should see these where it says firmware version, and then scan your pick to see UID, SAK, type, and data blocks. That's all you'll see at first. Card in front of it, and make sure you hold it long enough. If you hold it long enough, it reads the entire card and then stops.
Hey, Chris.
You see all these? Yeah, Dave.
I'd like to just make a quick note here, something I realized a while ago. When I was playing around with this, if you increase your baud rate up to as much as 57,600, it will increase the speed of the read. So a lot of the reason it takes 6 seconds or so to read the whole card is just because of the dumping out to the screen at 9,600 baud.
That's cool to know.
So
yeah,
you can,
thanks for sharing that.
mine
I'll
reads
show you the
the
difference
whole
right
card,
now.
and I can read the whole card in about less than a second, and then dump it to the screen at 57,600. But
Nice.
there's
So
almost no speed improvement beyond that. So
okay, so we'll give that a shot.
Change it in the sketch, or just in the.
you have to change it in both the sketch, and you change the baud rate in the serial monitor in the bottom lower right hand corner.
Okay.
Yeah, so what he's talking about is right here. You always, when you're gonna, if you want to be able to use your serial monitor, you always throw that command in there, serial begin, and then you define the baud rate in parentheses right here.
Why don't you try it out?
I will try it. First, I'm going to just jump back and show them the difference so that when we change it. So what happens if you got a full read, you hold it there long enough, you're going to see all 16 sectors and all the data that's in each sector. You notice it starts at 15 on the left here under word sector and goes all the way down to 0. So you have sectors and blocks. But if I just swipe this card, which I just dropped on the floor, so I'll have to take me a second. If I just swipe the card quick and pull it away, bit of the data, and then all those failed timeout and communication, that's just because you pulled the card away before it could read all the data. So, you know, the quicker you swipe, the less it reads. The good part is most of that data is nothing. Those are all empty data blocks for the most part. What we're really interested in right now is this very first line, which says card UID. So what I'm going to have you do before we switch baud rates is, if you have a card, I would either take a piece of tape or a marker or something and go ahead and write that right on the card, because we're going to need it later. You know, you could write it on a piece of paper if you don't want to deface your card, but if you have a couple of them laying around, you're not going to always know which one's which, so you're always going to end up loading this sketch to figure it out. So I'm going to go ahead and do that right now because I didn't before. So mine is 33.5B 0335. We're going to need to put that in our code if we wanted to, you know, uniquely identify a card for different purposes. So like I showed you earlier, I could swipe my card, it throws the turnout. If I use the tag, and I can read that tag right now too. If I hold this tag instead of the card, there it goes. And you notice that has a different unique ID. In this case now, the unique ID is 66886E8D. And it'll repeat, you know, every time I do that, you'll get that same reading, because that's kind of like the locomotive address of that card. It's like every decoder, you put a unique address in. Well, these cards each have a unique address too. So now let's go try Dave's little thing. So if you look under let's see once, where's the, I got to go to the settings, right? Or file preferences. Is that where you change the baud rate for the program?
No, you just change it right in the program. Cancel
right, but don't you have to change it somewhere too?
Yeah, in the bottom of the serial monitor. When you open a serial monitor.
Oh, okay, that's where I saw it. So
yeah.
What was the actual number then?
57,600 will work.
57600. Whoops, why didn't that take 57?
Yeah, and I determined that's about the fastest that it will read it. If you go faster, it doesn't really improve speed anymore. So upload that.
Yeah, so at this point in time, you'll have to do a file save as, because it won't let you save an example with the same name. So info 57600. Hit save.
From shaker.
And then I'll go ahead and upload it. Hopefully it won't take as long this time. It usually doesn't after I've compiled once and it's got it in memory. Yeah, that's a nice little catch, Dave, because the reason, for what we're doing right now, it's not that big a deal, but one of the things I was thinking about is if you put an RFID, somebody needs to mute, please. If you put an RFID in your locomotive, let's say, or a caboose, and it just passes quickly over the reader, you're going to want it to read, depending on where the data is and how much you need to read, you're going to want it to read fairly quickly.
Yep.
Otherwise, you won't be able to read the entire card without stopping over the top of the reader. So this is a really good find for model railroading purposes if you're thinking of using RFID and readers in your track. I know Andy has talked about that. We're talking some nights ago about putting car data right on one of these chips and putting it right inside the car. Because you don't even need to have a big tag like this or even the key fob. They make very small ones if you need to. So, all right, mine's done uploading.
One of the interesting things too is that you can specify very specific blocks of data to read, so you don't have to read the whole entire card. You can read just a little bit of the card when you go over, when it reads it.
Okay. So now if you open your serial monitor,
yep.
If you look, you'll see there's a bunch of gobbledygook. That's because my baud rate is off. So you go way down to the bottom, and I'm going to make this smaller in case it's off the screen for you guys. Whoops. So way down at the bottom right-hand corner, you got your choice of all the different baud rates. And when Dave was saying it doesn't pay to go faster, you see how many bigger the number, the faster it is. But he was saying he tested them and there was no real difference. So big key is you got to match this number to what you have in your code, in your sketch. So now you notice the gobbledygook turned to English. Firmware version 092, basically exactly the same as what it said before. I'm going to go ahead and swipe my tag. Oh, wow. Sweet. And that was a quick swipe when I got over half of it in about a half a second. So I'm guessing I only have to hold this for about a full second to get the whole. About a second and a half gets you the whole card now.
Yep, that's pretty good.
Here's my other card versus the 5 or so seconds it took me before to read the whole thing. So now if you would happen, if we get into writing to these cards sometime, more than likely we could write in these blocks up here and you could swipe super fast and make sure you pick it up, and who cares if you don't pick up the rest. So if I just quick passed over like a really fast train, I'm still picking up the first 4 sectors, at least 4, even 5 sectors, just by passing over at a very quick speed.
Well, the other thing on there is you don't have to read the whole card when you read the card. You can specify and say go to sector 1 and read block 1 out of sector 1 and just give you that data. And so then that would once again give you a speed increase because you don't have to read the whole card. It identifies that a new card was scanned or was just hit, and then it requests right away just that little block of data, and then you're good.
Like we talked about it at offline show previously, is just write the card or the freight car number, maybe nothing more to those first few bits. And we could write all kinds of information like where you purchased it, how long you've had it, what the real weight of the car is, all kinds of other stuff you don't care about for inventory purposes. But if you're using it under your track, as I intend to, I won't have to read anything other than about 4 to 6 bytes of data.
Yep.
So, everybody have good luck being able to read your card and write down the number.
Absolutely.
Yep.
All right. Well, good. And how about Johnny? Is everybody out in the chat room or on the YouTube? Any questions or? All right. So at this point, we just got our number and we read our card, and this was the first step. I'm kind of walking you through the whole step of how I developed this. So when you want to try and develop things on your own, the first thing I knew was I was going to have to verify that my RFID card reader was working. And of course, I knew I would need an address. So this simple sketch allowed both of those. If you can't read your card right now using this simple sketch, it means it's not wired right, and you're not going to be able to to use the other sketch. So, or if you're, you know, developing some other purpose that you want to use this RFID on your layout. So this is a nice little fallback just to test it. Or maybe even if you get a new reader and you want to test it, you know, this is a good way to do it. The next thing I needed to do, and I'm not going to actually go through it, was I needed to figure out, all right, so I can read the card, but now I need that card to trigger a servo. And not only do I want it to trigger the servo, I want it to throw it back the opposite way the next time I swipe. Now, like I was saying earlier, I found a whole bunch of sketches that you could swipe once and the servo would throw, and that would be it. Or usually it would throw and then wait a certain amount of time and then come back. So it would just repeat the same process in a single direction over and over and over. I really couldn't find until I found one website at the nscaler.com. The guy's got a really nice website with a lot of good Arduino stuff on it. And I was able to find the sketch that we modified and used in one of our earlier Arduino workshops, where I could push the button and the servo would go one way, push the button again and it would go back the other way. Because even with the push button, it was very similar for servo sketches. You'd find where people were using 2 push buttons, one to make it go left, one to make it go right. Or maybe using a rotary knob or something to do that. Well, I really didn't want that, because I knew the goal here was to use one card to swipe it and have it go left, and then the next time you swipe it would come back right. Or in railroad terms, normal, reverse, closed, or thrown. So once I went ahead, and this was fairly simple, all I needed to do was wire in the push button and a resistor, which was basically for debounce, and a couple wires back to this servo, or to the Uno, and I was able to, and of course the servo, which is very simple to hook up. We've done that before, and we're going to do it again in a few minutes. It's only 3 more wires. So I was able to successfully throw the servo left and right using the push button. So now I knew it was just a matter of marrying the 2 codes together. But what I hadn't done, and what I was having trouble finding out how to do, even going through other RFID code for other purpose, was how do you take that read and then feed it into the servo to tell it to actually do something. So that's where it took me a little bit of time to figure that out, because I mean, it's one thing to read the card and get some data, but now you need some programming to tell it to take that data and activate something, whether it was, and that's what I ended up doing, is I found a sketch that, you know, just simply lit up an LED. So that gave me the bridge between RFID as an input and feeding it to some kind of an output. Then it was just a matter of making that output my servo instead of an LED. So by combining the reading, the push button, activating an LED with the RFID, and then actually connecting a servo, I was able to come up with the entire sketch and make it work after a little bit of time. So let's go ahead and do that. And first thing we're going to do is grab a servo. And let's, in fact, go to my Google Drive that I gave you the link to. You'll see there's 2 sketches in there. The first sketch is one if you wanted to play around with that push button or see what the push button programming was. That's what that sketch is there for. The second sketch on the list, the one that, let me see what it's called again here. Or if somebody wants to read me, I'll tell you if that's the right one or not.
Throw servo. It says throw servo.
And then what's the rest of it?
Well, it was RFID specific tag throw servo V2.
Yep, that's the one. So the reason I named it that was it throws a servo, but it needs a specific tag. In this case, I wrote down the tag number, and hopefully you guys did too. Not just a generic any tag. So that's why I call it specific tag. So go ahead and that INO, if you copy that, download that to right click and hit download, you should be able to download it to your computer. And then you go ahead and double click on it, and it's going to give you an error message saying, hey, this needs to be in a folder. Do you want me to do that? Say yes. And what it'll do is it'll load it into your Arduino library in a folder of the same name and go ahead and launch it for you in your IDE. So One more time, just download it, double click on it, and then when it prompts you, just say yes, allow it to write the folders, and it will end up opening in your IDE. I'll give you 30 seconds to do that. While I make some more Mountain Dew disappear. Okay, so I have mine loaded already, and I'm going to go ahead and screen share with you. We'll take a quick peek at the code, and then we'll wire up the servo, and we should be able to run it. See this?
Yes, sir.
Okay. So I kind of left some of the remarks at the top, and I added some of my own. So the first part I needed was the RFID reading part of the code, and I got that from a tutorial at randomnerdtutorials.com. And those notes, I left the credit from the guys who originally did it, created by this guy, modified by that guy. Then I added my own, modified by CDH. Anytime you see that in the comments, that was me. So I marked my own code so I knew which stuff I did and which stuff was original codes in case I screwed something up. So I put a lot of comments in here just because it was helping me. And I'll tell you one thing right now, programmers will probably turn their stomach when they go through this because it's not pretty, but at least it works. I didn't have time to go back and clean it up. I was up till midnight on Monday working on this, and last night I didn't have a lot of time. I was going to clean it up. So it works. There's probably things that can actually come out of this code. It definitely needs to be cleaned up, but at this point in time it is functioning. So to go through it real quickly, there's 3 libraries we have to load. One is spi.h. I think that's a standard library that's included with Arduino IDE. The next one is the MFRC 522 library that we used for the last sketch that we just did. And then, of course, the servo.h, that one is also included. So the first 2 libraries were part of the RFID sketch that I used as the base for mine. Then knowing that I was going to be working with a servo, I added that we have to use the servo library too. And so the first thing I did was create a servo named my servo. And then I actually just put in a bunch of the servo information. This first line, these couple you're going to want to pay attention to because these are going to have to, if you end up building, throwing turnouts with it, you're going to want to use these 3 lines right here. The step delay is how fast the servo moves. So this was originally set at 10 because the servo portion of this I also copied out of the one from the N scaler. In fact, did I have credit? Yeah, if you look up in the credits here, the servo portion was based on something I found at this 14core.com. Some of the concepts and some of the coding I got out of there, and the rest was modified from the sketch at the nscaler.com. So I put links to those in case you want to go back and investigate them. So anyways, the step delay was already at 10, and that moved pretty fast because remember, these are milliseconds. So I kept bumping it up while I was online with the guys the other night, and I got to 250. I thought was a pretty good, nice, slow speed. If you want it slow, if you want it faster, just make the number smaller. Then I set these 2 constants, integers that are these are the positions of the servo. You remember a servo goes from 0 to 180 steps, basically, that, as we talked about in our previous servo workshops. So you need to kind of find out where, and this is going to vary, these numbers will vary for everybody, because when I mounted the servo under the board, it's not going to be exactly zeroed. It was close, but not quite. And then how far you want to throw left and how far you want to throw right. That's what these numbers are. So in the servo world, 90 would be 0, basically centered between left and right. So when I got done with this, I ended up changing for the straight ahead route is 95. So I was a little bit off center. And then to go on the diverging route, I have to move the servo to position 108. So those are just the left and right end stops, if you will. If I would make this number lower, like 70, it's going to push well beyond the point where the point rail is touching the stock rail on your turnout, and it's going to try and start bending your wire. And then what happens is it'll kind of move back by itself, the servo will, because of the tension. And the next time you throw it, it literally tries to go back to the original spot it should be and then go move the other way. So it's really kind of weird. It kind of, if I was moving the turnout to the right, it would go to the right, and then you'd see it kind of trying to go farther and then end up stopping. Next time I go to the left, it would literally jerk back to the right before it went to the left. So you just tweak these numbers till you get a nice smooth action, and you stop where your point rails are touching your stock rail. And I'll show you that later on when we get back to activating the thing. So those are basically your left and right end stops anyway. So then we have to define what you have to define which pin is going to be the servo pin on your Uno. And then this is the cool part of the code that I give the N-scaler credit for. This is the nice part, how I got it to go left and then right each time you trigger it, whether it's one button or a swipe of the RFID card. He uses this position equals straight, old position equals position. It sounds a little weird, but basically all what it's doing is it's remembering where it was last. And then when you trigger it again, it'll go to the opposite. And it just does that by rewriting. As soon as it moves opposite, it rewrites that as its new old position, and it just always compares. So every time you swipe it, it'll flip-flop. I'm not going to get into the nitty-gritty details, but if you're interested in finding out and figuring it out, and you're pretty good with code, this is where to start looking, and then follow it down through the rest of the code. The rest of this is pretty much our standard, defining your pins, creating a library instance, and then we actually get to the void setup, attaching your pins. I added this one right in here to actually go ahead and move the servo right away to a position other than 0. Because if you turn on your layout, you wouldn't want your position to center. You'd want it to go to the left or to the right. And I actually should have changed this back to 108 or to 95, depending on whether I want it to start out in the straight ahead position or the diverging route. But this line of code will allow you to tell it where to start when you first turn on the layout, if you want that turnout to be straight ahead or if you want it to be diverging, depending on where the turnout is. So match this number to one of your numbers up on top right here. Let me scroll up a little further. Whichever one of these two numbers you want it to be, I would match one of those two numbers. Otherwise, when you first turn it on, it centers, and then it'll sit that way until you actually throw it. So if you don't want to have to throw every turnout on your layout every time you turn it on, you want to have it go to a good position. In other words, a close that it's not going to derail anything. So that's what that line of code is for. Then here's the little thing that I modified myself to. I put a 2-second delay in there, or 2,000 milliseconds, and I found out previously that if you detach the servo, it's like turning it off. If you don't detach it, these servos can buzz. I know a lot of you guys ran into that when we played around with servos before. If you leave them powered up all the time, even though they're sitting in the position they should, they make a buzzing noise. So by detaching it, I found out it'll stop doing that. Then all we have to do is simply reattach it right before it has to throw next time. So that's why I went ahead and put it in position, waited 2 seconds for it to get there so it doesn't detach before it's done moving, and then I detach it. So that's in the void setup. So this is strictly for when you first power on the layout. Then we go through starting your serial monitor in case you wanted to monitor it. That could be commented out. Then you initiate the SPI bus so your RFID can read. I know this is sounding a little technical, but for those that want to know what that's for. And then serial print, if you are running your monitor, it'll tell you, hey, put your card to the reader, and then it'll print whatever it reads. So I haven't actually used that. This was just actually legacy code that came along with the stuff I got up here. So it could probably be commented up and cleaned out if you're not ever interested in reading your serial monitor for what we're doing, but it would help if you had to troubleshoot. What you could do if you don't want any of that is just put the old // in front of it. That turns it into comment. And then if you ever decide to do it, you just take the 2 slashes out and then it becomes code again. Then we get to our famous void loop, and this is where all the action happens. And this is where I'm not going to get too complicated. But it's basically, in a real high summary, what it's doing is it's telling it to look for a card. In other words, is there a new card being read? And if not, nothing really happens if there's no card in front of the reader. And if there is one, then it's going to basically compare the UID, and that's what all this code is for, and I don't even fully understand it myself. All I know is it works, and I'm happy. And if you wanted to take your time and read this, but it's basically all this code from here all the way down to here is all telling it to look for a card. When a card is present, read the card, and if the card has the correct UID, then to go ahead and do something. And here again, there's some serial monitor messages in here to read what's going on if you really want to. So once it finds a card that it likes that matches the UID, and matter of fact, I'm going to show you back here where to put that UID in, because that is important. Let's see here.
Chris, that will actually show the card that you're reading in the monitor if you pull it up. So if you didn't want to run that other program ahead of time, you could see it.
Oh, okay. That's good, because I didn't actually try that, so that's good to know. Very good, thanks. That's why I like having other people on here. That we're all learning together. I got to find where that is. Somewhere in here, it's well hidden. It must be way up at the top. Let me go back up here.
Line 76 has the card ID on it.
What's before? I don't have my lines numbered, so.
Oh,
there it is.
Keep going down. It's right there.
I got it right here.
2 lines. Yeah.
Yeah. So it says if content, in other words, if what it's reading is 33-5B0335, now you're going to have to take this sketch and change that number to your card, or this sketch will not work for you. So right here, this is very important. You have to take your number and insert it here. Your number should be 4 sets of 2 numbers or alpha characters. They're really kind of random. My other card had, you know, an alpha character in the 3rd and 4th set, where this one only has one in the 2nd set. But so right now, go ahead and type your number in there and hit save. So as I was saying before, this, you know, this whole set of instructions right here from here on down to there is just basically saying read a card, and if the address is correct, then we're going to move on and do this stuff. So this old position equals position, this is going back to now setting it. Now you'll see these POS and the old POS, and that doesn't stand for piece of sugar. Stands for position. So those, every time you see that, it's basically doing a comparison, saying, hey, if I was over here, I'm going to move over there. If I'm over there, I'm going to move back over here. So without getting into the nitty gritty of it, that's pretty much what it stands for. So then we get to the servo. So right now it's read the card. It says, yeah, hey, that's a good address. And now it says, all right, what position am I in? And what position am I going to move to? Once it does that, determines that, then it goes ahead and attaches the servo. This is where I added that code to now reactivate that servo, because remember, we turned it off when I detached it so that it wouldn't buzz. And then it goes and starts going through the if statement again to, this is more of the figuring out where it is and where it wants to move to. As you can see, that's quite a bit of elaborate code for that simple thing of going from one side to the other when you push a button or swipe a card or activate any kind of sensor, whatever your input method is. It's not as simple as you would think to just simply have a toggle back and forth. It takes quite a bit of elaborate code there. And finally, at the end here, and in fact, I think I can comment some of this might be redundant code. In fact, I did comment that out. No, I didn't. I think that was part of the area I was going to be cleaning up. But I'll go ahead and attach the servo, write what the position is, and then when you do this my servo.write, that's actually issuing the command to the servo, and the servo will do what it's supposed to do. Then I put in the 2-second delay, and then I go ahead and detach it again so that it shuts off until the next time you swipe it. That's kind of your program in a nutshell. Like I said, it turned out to be a lot more involved. I thought, how can it be to swipe a card and throw a servo left, swipe a card and throw it right? Well, now you can see it's not as easy as I might have thought. But the good news is I did it for you. You now have a sketch, and now we can start a new trend in model railroading, and that's throwing your servos with RFID. You saw it here first. So if the sketch is all ready, I'm just going to double check. All we really had to do was change that address to your card, or the UID for your card. I think everything else will end up coming back in here now and changing these two numbers later on. In fact, if you want to change them to a bigger number right now or a lower number, take this straight and change it to like 20 or 40, and then go to the divergent and set it way out at like 140 or 160. What it's going to do is give you a bigger swing on your servo so you can really see it. You know, mine moves so little just because it's throwing the switch right now that you won't see a whole lot. But if you want to go ahead and change that right away. And the other thing you can do is pick out of this code real quick what we have to hook up for the servo. You see this little servo pin 3? Well, now we know what pin we need to connect our servo to on the Uno. So I'm going to stop sharing and I'll show you how to hook that up right now if you haven't figured it out already. Hopefully you guys are getting good enough now that I know the guys on the panel probably are, and hopefully the guys out in YouTube land are too, getting good enough now that as soon as I say, hey, we're hooking up a servo, you know exactly what to do other than what pin to connect it to on your Uno. So my servo has these, the orange, the red, and the brown with like white, red, and black, or sometimes there's even a yellow. As we learned before, the one thing you remember is that the center pin, or in this case the red one, is always the power. So you're going to want to take a wire connected from the center pin on your servo to 5-volt on your Uno. Or if you're using a separate power supply, you know, you can connect it to your breadboard and then connect your power supply. It's really a good practice to do that. I'm only using one servo, and they're a small servo that doesn't overload the Uno, but if you're using a bigger servo or multiples, you never want to power it right off of the Uno. It's okay for just one. And I bet you if I gave it a separate power source, it probably wouldn't buzz either. I may not even have to use the detach command, but it was a good little trick I figured out, and I'll use it for now until I get a separate power supply. So the next thing we want to do, in this case, if yours is black, it'll have a black one on the right instead of the brown. If you have the brown, those are that's always the ground. So go ahead and wire from your black or your brown to ground. And the other one that's left is your control wire, which we go to pin number 3, which we saw in our sketch. And I'm going to double check real quick. When I had it hooked up to 8, I got the number 8 stuck in my head, but that's when I was using the push button. Actually, my push button sketch had it going to pin 8. So yeah, it's pin 3 in this sketch. So like I said earlier, this is really a simple to wire project. All you're doing is your 7 wires from your RFID and 3 wires from your servo, and that's it. We don't need a breadboard or resistors or any of that stuff for this project. So I'm going to go ahead and upload the sketches, and if you guys are at this point in time, I would suggest you do the same. And we'll see if it works for you. So how's my quality holding up as far as sound and picture? That's good. Okay. So mine's a little slow. Hopefully you guys rip right through yours and you're already having fun moving your servos. I'll take a peek here and see. Anybody got one to show that they're finished with already?
I'm afraid I don't have a servo to attach, but the rest of it's working.
Oh no. You should have told me.
I have mine up and running.
Okay. There you go. See, and if you don't like it moving that slow, then you can change the number on, at the beginning of the sketch that tells it how fast or slow it goes. So now swipe it again, see if it go back the other way.
Actually,
there you go.
just sit there and hold it, it'll bounce back and forth. I saw that.
Yeah, I'm sure there's things to improve the sketch, and I know there's definitely ways to clean up the code. But yeah, there was. I figured out something too. That
that's because it's in that loop. So I mean that's perfectly acceptable in my mind.
But you could potentially put a timeout or something in the code that would keep it from doing, and a delay or something that would maybe keep it from doing that.
Certainly.
You could say don't go back the other direction until X amount of time has passed or something to keep it from, kind of like a deep bounce, if you will.
Exactly.
I was going to say, I did that with my push button sketch because I want to use a single push button since I'm going to use read switches to toggle my turnouts. I didn't want you to accidentally hold the magnitude log or to hit it two times so quickly. So I used the bounce. I may try to pull that and integrate these 2 bits of code.
All right, so mine's done uploading, and I'll go ahead and mine is okay. So let's see what happened here. Now I'm gonna try and get that. Got it on the wrong side of me. There. Mine's moving very slowly. And very slowly back again. But as you can see, that's why I had you bump the number up, because it's probably really hard to see and it's moving such a little amount.
It looks good.
But what I did, so here underneath this board, you can see how thick that board is, and this card will actually read through that board. But one of my homemade 3D printed servo mounts. But you see, this is the way I like to mount them, and that long wire, magnifies that short throw considerably. By the time you get way up here, ½ an inch away, that small movement in the arm is magnified considerably. So that's why the servo is hardly moving. It's just like being out at the end of a whip. Down toward the center, it's not moving much. Out at the tip, it's moving a lot. So now what I'm going to do is simply unplug this servo and plug in the one on my sample board, and we'll go back to showing that off again. And that's pretty much it for what we needed to do to make this work for tonight. So if we want, we can kind of go back in depth and cover this a little, or if anybody out there in YouTube wants a little help, we can get out there and help you with it. All right, so I'm gonna, unfortunately, there's not enough room for all of this stuff in the picture at once, so there, how's that? So right now you see it's in the straight ahead position. I'm going to hit the reset button on my Uno. and you notice nothing happened. Because this goes back to that one line of code where I told it to, it probably moved a tiny little bit, but not enough to move the points. So if you remember, I had the value at 108 or 102 instead of 108. So that basically, when I turn this on, I'll show you the difference. So I'm going to go ahead and throw it to the other side. Whoop. I guess it just never moved because now it's just threw back. So I'm going to throw it to the other side, and I'm going to go ahead and reset the Uno again. And you notice it jumped back. So that's what I was trying to show you is, what position do you want this to be in when you first turn on your layout, fire up the Uno and everything else. You don't want it to stop in the middle, because then if nobody ends up throwing it for the first half hour, first train that comes through is going to derail because the points are centered. So that's why I added that line of code. If it's already in this position, see, there was a little jump again. I don't know why I did that. If I throw it back, throw it back there. Now if I reset the Uno, it shouldn't really do anything. Yeah, see, it didn't move at all. Well, that's weird why it jumped all the way over and came back, though. It wasn't doing that before. Might have been something I was doing when I was cleaning up my code. So now if I turn it off, reset it one more time, it should, there, it came back by itself, but not quite all the way. So that's where that 102, 108. The other thing is, now if you notice, if you see way back in the distance, let me see if I can move that in a little closer. When I swipe this card, you see that red light going on my Uno in the back? It's reading this card, but what it's saying is, oh, hey, wrong UID. I'm not going to throw anything. You'll see that same light go on when I do this. See that red light flashed? Every time you put your card there, you'll see that red light activate. But you notice the difference. As long as I hold this here and it's wrong, that light is staying red. And I pull it back, it goes off. When I put this card on, it only flashes momentarily. And as long as I hold it, it doesn't come back on. So I'm guessing that has something to do with the programming that, hey, accepted or not accepted. So it reads this card, it accepts it, so that light goes out. It reads a card that it doesn't like, the light's going to stay on as long as it's reading that card. Just a little something I noticed while I was playing around with this. So,
I mean, it's just because it's writing that data out. Well,
yeah, that's exactly what's happening. Is I noticed that when it reads the card, a valid card, it says authorized access. I'm just watching the serial monitor, and it says that only once. But when you have a bad card, it keeps repeating over and over and over again the ID of the card.
okay. Look.
Okay, well, yeah, that would make sense, because when it reads a good card, it moves forward to the whole servo portion. But if it doesn't read a good card, it loops back to the beginning. So as long as you hold it there, it's in a tiny little loop, like read good or bad. And every time it's bad, it goes back to read. Read good. It would jump down to servo. Read bad, it goes back to the top. So it's just continuously cycling, reading the card bad, read the card bad, read the card bad, read the card bad, and then all of a sudden read the card good. Oh, okay, now I can move forward and do the rest of my commands. So that's what that loop, void loop, is all about. It just loops that thing around tens of thousands of times a second. So it looks like the light is on constantly. In reality, it's going on and off probably 10,000 times a second as it reads the card, determines it's bad, goes back to the top, read the card bad, read the card bad, as fast as it can do it over and over. So that makes sense. So you guys got any other questions or anything? Otherwise, we'll cut the wraps. Oh, I know. I'll talk about next time. We're going to go ahead and start building a speedometer. I found multiple ones out there, and we're going to start with a simple one. And if we like it, we'll go ahead and work toward a more elaborate one. I know there's a nice one out there, and one of our members actually built it. And I remember seeing a video a couple weeks back. But I'm going to keep it simple for now. So I found a simple one that I actually like that should work. I'm going to build it, order the parts, and try and build it in the next week. But I'll get you the list of parts posted up to the Google Plus page, and I'll also post them to my new website, just so that they'll be there for a while. So if you save that link from tonight to get to you can kind of use that as a source of information for sketches that you need, and I'll keep the sketches that we've used in there, as well as the parts lists, in case anybody ever needs to refer back to them. And no, the Google Plus is good, but what happens is that stuff gets pushed so far down the list eventually as more and more stuff gets posted that it gets hard to find. So this way it'll all be in a easier to find format on the website. And maybe we can get that moved over to the actual Google or the Model Builders, YouTube Model Builders website one day maybe. So any other questions, comments, discussion, things you'd like to see in the future? Otherwise, we'll...
Nice job, Chris.
Well, thank you, Dave. And Andy, I look forward to that computer. I really appreciate that. That'll help improve this show for everybody. So.
Oh, absolutely.
It's not just me. It'll benefit everyone.
Absolutely.
So, all right.
It was great.
Not much power, but also if whatever or whatever hardware you're thinking about for the speedometer, especially if it's different from the one that like Lloyd had worked on, because I know some of that. If you could get some of that together for us and share it with all of us, and so we can get it posted out in the community, so anybody watching this night live or after could go procure that hardware prior to that show.
Yep. Yeah, that's what I was saying. We're going to get the parts list posted, and probably by Monday, I would think, if not before. I'll try to shoot before that, but I got a pretty busy schedule again the next couple of days, so as soon as I can get that posted, I will.
Oh, that'll give most people plenty of time.
Sure, that'll give them a month basically to get your parts. So, all right. Well, thanks everybody for watching. I hope you learned something. I know I had a lot of fun with this one. It's fun to actually apply it, and then, just by coincidence, when I was out there, I wasn't able to find any reference to this ever being done before. So this could be a first. Maybe it'll catch fire. You never know. And not in a good way, not in a bad way. Not burn up your layout. But, oh, I did.
Usually you don't want to catch fire with electronic project.
But the neat part about it, if you go out, all it requires is a servo and this RFID reader. I mean, these are like, you can buy them in bulk for probably $1 a piece for the readers. And you go buy the Nanos or Nano Pros. Those are only a couple bucks a piece. I mean, for less than $5 a turnout. I mean, nowadays you go buy toggle switches, you're going to pay $1 or $2 for them.
Yeah.
So if you're looking for that clean facial look like I'm looking for, this is a great solution. I'm looking forward to, in fact, hopefully by the time we do the speedometer show, I'll actually have one installed on my layout, and then I'll show you that too. So it's rather than just a sample board here. So, all right, Johnny, take her away, close her up, and I'll see you guys in a month.
All right. Thank you, Chris. That was very interesting. Alrighty, let's get on over here, and I want to say thank you, Chris, everybody on the panel for coming in. Well, let everybody know that go to YouTubeModelBuilders.com. There you can check schedules for the shows, the Tuesday and Wednesday shows. Those are at 8 o'clock Central, 9 o'clock Eastern Time. The Thursday and Saturday once a month live show with Big Bill and Barry are at 9 o'clock Central, 10 o'clock Eastern Time. Thursday shows are at every Thursday of each week, as everybody knows. Be sure to click on the e-mag. Sign up for email notifications when it comes out. JD and his team do a great job. The last issue just came out about a week ago. Next week, August the 8th, we've got a layout tour with Miles Hale. That's going to be interesting to watch. See, he's going to be touring his layout there at his house to show what he's been changes he's been making. So show off what he's done. He's found some really interesting stuff for doing backdrops. So I know everybody be interested in seeing that. So be sure to check out YouTubebuilders.com and Chris's link there to where you can download sketches. And I believe there should have been a tag, a tab on the YouTube channel so that you can get the Arduino stuff there or any other electronic stuff. Also, want to let everybody know these are recorded shows, so if you came in late, missed the first part, we did have a couple people come in late tonight, but yeah, alright, next, but the shows are recorded on the YouTube channel, YouTube Model Builders, and they are in playlist. You'll find this under the Wednesday night or the Arduino playlist. And let's see, Brunette wants to know what's the next class date. Let me look over here and see. That's going to be September. Alright, Brunette, that's going to be September the 6th. The shows are always the first Wednesday of the month. So it'll be September the 6th. You mark your calendar. 8 o'clock Central, 9 o'clock Eastern time. I want to thank everybody for coming in tonight, watching the show. Thank you, Chris, Dave, Andy, Craig, for being on the panel. And we shall see you tomorrow night for the Thursday night show. That's going to be 9 o'clock Central, 10 o'clock Eastern time. So y'all have a good evening. We'll see you tomorrow night.